The human mind is capable of contemplating the infinite, yet it remains fundamentally shackled by its own biology. We interpret reality through a narrow lens evolved for survival in a world of height, width, and depth. These three axes, X, Y, and Z, define the rigid parameters of our perceptual cage. Every object we touch or location we visit is restricted to these coordinates. But mathematics suggests that our inability to see a fourth direction is a failure of our eyes, not a limitation of the universe. Just as a square can be extruded into a cube can theoretically be extruded into a space we cannot visualize. In the 19th century, mathematicians broke the three-dimensional barrier by introducing a fourth W-axis. This created two new conceptual directions, ana, which moves up toward the fourth dimension, and kata, which moves down from it. Because human intuition is a product of our 3D environment, it is an unreliable narrator of higher dimensions. To grasp the true structure of space, we must rely on equations where our vision fails. Building a four-dimensional structure follows a consistent geometric logic called extrapolation. It begins with a zero-dimensional point, a single location with no size, stretching into a one-dimensional line. If you sweep that one-dimensional line perpendicularly to its original direction, it traces out the area of a two-dimensional square. By sweeping that square perpendicularly along a third axis, depth, you create the familiar three-dimensional cube. Finally, we apply the rule to the unseeable. Sweeping the entire 3D cube along the invisible W-axis creates a tesseract, a hypercube with 8 cubical cells and 24 square faces. A true tesseract cannot physically fit within our three-dimensional world. To study it, we are forced to observe its shadows, lower-dimensional projections that require a radical shift in how we interpret shape and volume. Around the turn of the century, these abstract mathematical theories leaked into popular culture. In cities like Paris, the fourth dimension became a shorthand for a reality that transcended the limitations of the senses. Some sought a mystical explanation. Victorian spiritualists, led by Johann Zollner, claimed the fourth dimension was a physical location where ghosts and spirits could perform feats that were impossible in our three-dimensional space. Others sought to train the mind. Charles Howard Hinton, who coined the term Tesseract, developed mental exercises and colored cubes designed to help people visualize these higher dimensional rotations. Modern artists saw the math as a tool for revolution. Pablo Picasso utilized 4D theory to develop cubism, painting objects from multiple perspectives simultaneously to suggest a four-dimensional view where all sides are visible. Marcel Duchamp took a different approach. He attempted to capture the fourth dimension by painting the passage of an object through time, creating a visual record of motion that exists beyond a single moment. Through these experiments, art became humanity's first visual language for the invisible, acting as a bridge between cold equations and human experience. While art and mysticism treated the fourth dimension as a hidden spatial direction, theoretical physics was discovering that it was actually the fabric of the universe itself. In 1908, mathematician Hermann Minkowski proposed that space and time were not separate independent entities. He suggested they were inextricably linked. Albert Einstein adopted this framework to complete his theory of general relativity. He realized that the mathematical laws governing four-dimensional geometry were the only way to accurately describe gravity. This is the space-time continuum. In this model, time is integrated as a fourth coordinate within a mathematical manifold. This fusion allows us to define any event in the universe, not just by its location, but by its precise moment on a four-dimensional fabric. By treating time as a physical dimension, physicists could finally calculate the motion of the cosmos. This geometry explains why light bends around stars, and why time itself slows down as you move faster through space. Mathematics' indifference to our biological limits is humanity's greatest liberation. It proves that human reason can map the true nature of reality, even when our eyes remain trapped within the prison of three dimensions.